today's objective is to learn a third and final way to solve a quadratic equation, to figure out what x equals, to figure out our x-intercepts, our roots, our zeros, depending on the notation. So we've learned how to solve by square roots when there's no b term or in vertex form. We learned how to solve by factoring as long as the problem is factorable, by factoring and setting your factors equal to 0. And today we're going to go ahead and learn the quadratic formula. So either at the end of class yesterday or the beginning of class today, you worked on a handout that talked about how to simplify at the very end of the quadratic formula. Well, today we got to learn what that formula actually is and how to apply it, and then we can apply those strategies. So I'm going to go ahead and write down the section number still. So we're still in that same section 2.5. We are on day 4 out of 10 days. So solving quadratics using the quadratic formula is today's goal. Okay. First step is you have to set the equation equal to 0, just like we had to do with factoring. Second step, we are going to input our A, B, and C values from standard form into the following formula. I'm going to write the formula down. It is the long one that you would have learned at the end of Algebra 1, and I will sing a really corny, silly song that will help you remember it. It's going to seem stupid, but I have had past students come visit me, and they're like, oh, in my college class the other day, I sang the song in my head, and it helped remember the formula. So you can fight it all you want, but it is catchy, and it can help you memorize this formula because you'll have to have it memorized for quizzes, tests, and on the midterm exam. So it's x equals negative b plus or minus the square root, and under there is b squared minus 4ac, all divided by 2 times a. That is the quadratic formula. The way the song goes, I think it goes to that like Monkey Chase the Weasel song or All Around the Mulberry Bush. I don't quite remember. I should know though as a mom of toddlers. But it goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. And I know I can't sing. I apologize if you have to listen to my voice. But that's my version of singing that song. Normally I would have you guys repeat it with me like 3 to 5 times, but I am teaching to an empty classroom right now. So I'm going to pretend that you're all singing with me on the count of 3. 1, 2, 3. X equals negative b plus or minus square root b squared minus 4ac all over 2a. The all over 2a is an important part because a lot of people forget to put it over the whole thing. The nice thing about the quadratic formula is it can be used to solve any quadratic in standard form. Square roots had its limitations. It couldn't have a b term, or it could be in vertex form. Factoring has its limitations. Not all problems are factorable, but the formula will work for anything. So why do we need it? You don't have to write this down, but at least listen. Say I gave you this equation. 0 is equal to x squared plus 6x plus 10. I can clearly see right here it has a b term, so square root's out. The square root method is out. I could attempt to factor it. The a value is 1. Factors of 10 are 1 and 10, or 2 and 5. When the a value is 1, those are supposed to combine to b. None of those work. Therefore, factoring is also out. Instead of just giving up, we need a third method. So if I wanted to solve this, I could use the quadratic formula. It's going to come to the rescue, where you would sub the a, b, and c values into that large formula and simplify it down to get your solutions for x. The formula tells you your x solutions. So let's practice it. So first one we're going to do is 3x squared plus 4 equals negative 5x. Have to set it equal to 0, just like with factoring. So we're going to add that 5x over, and put it where it goes. That's our b term, so it's going to go in the center. And we will get 3x squared plus 5x plus 4. Just like with factoring, it's much easier when the a value is positive. You can do the formula with a negative a value. There's just a lot less chances for error when you're using the formula if a is positive. So I would encourage you to move the terms to whatever side that would keep your a value positive. So my a value is 3, my b value is 5, and my c value is 4. Those are now going to be inputted into the formula, which I will sing while I input those values. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I'm subbing those numbers in to their locations. Now comes the simplifying part. Take your time, don't rush it, watch your signs, and see how far down you can get. I'm going to bring down the negative 5, plus or minus. Underneath the radical, I'm going to square the 5 and multiply my 4ac. 5 squared is 25. And I like to count how many negatives I have with the 4ac. Right now there's just one, the first negative 4. One negative means it's going to stay negative. 2 negatives change positive, and 3 negatives, an odd amount of negatives, would still stay negative. 4 times 3 is 12, times another 4 is 48. And this is now all over 6. Can still combine underneath the radical. Those are grouped together. That's going to give me the square root of negative 23 all over 6. Once you get down to the radical part, there are 3 options that can happen. Either that number is a perfect square and the number gets to come out as a new number. For example, if it was a square root of 9, it would come out as 3. Okay. The other option is you try to break the radical apart by simplifying it. So if it was radical 8, I could break it apart into radical 4 times radical 2. Or the last option is if I can't do either of those, it's just going to have to stay inside the radical. So there is one thing that can come out, which is the negative. Negative under radical comes out as I, as we reviewed during the complex number system. But 23 is not a perfect square, so it can't come out. There's no perfect squares that go into 23, so you can't break it apart. Therefore, 23 is going to have to stay under the radical. So I will get x equals negative 5 plus or minus. The negative did come out as I, though. Radical 23 all over 6. Just double check to see if every term has something in common that you could divide them by. But 5, this would be a 1 in front of the radical. 5, 1, and 6 don't have any common factors besides 1, so this is as far as it goes. I know it looks complicated. This is 2 imaginary solutions. One would be negative 5 plus I radical 23 over 6, and the other would be negative 5 minus I radical 23 over 6. So that is 2 solutions, 2 imaginary solutions. And this, if I were to graph the function once I got everything to one side, it would not cross the x-axis. Try another one. So I'm going to go ahead and give you guys, sorry, I lost the paper with the examples I wanted to put here. 4x squared plus 8x equals x squared plus 35. Move everything to one side, trying to keep the a value positive. If I move the 4x squared over to the x squared, that'll become negative. So I want to move the x squared over to the 4x squared to keep it a positive a term. And then I'm also going to subtract the 35 over to get everything on one side of the equation. So I will have 3x squared plus 8x minus 35, and that's now set equal to 0. What I want you guys to do is you don't have to do the whole formula yet, but I want to see if you can at least sub the numbers into the right location. So identify your A, your B, your C, sub them into the formula, so hit pause and check to see if you got the same thing I did. I'm going to keep going and sing my song. X equals negative B plus or minus square root b squared minus 4ac all over 2a. That's what it should look like after round 1 of inputting your numbers. Keep working underneath the radical next. Don't lose any pieces. Square the 8 to get 64. This time when I count my negatives with 4ac, I see two negatives, a -4 and a -35. When I multiply two negatives, this will change to a positive. So I've already predetermined my sign, so I can ignore my negatives now when I multiply. I'm just going to do 4 times 3 times 35. I'll do that out on the calculator. 4 times 3 is 12. And then I'm going to go ahead and do 12 times 35 to get 420 all over 6. This is going to become -8 plus or minus the square root of 484 over 6. As I said prior, once you get down to the radical, that radical has 3 options. The number comes out, you break it apart, or it stays in. With larger numbers that you're not as familiar with, always check to see if it's a perfect square that you don't know. So on my calculator, if I take the square root of 484, I get 22, a whole number. That means 484 was a perfect square, just not one we knew. It comes out of the radical as a whole 22. So I'm going to get -8 plus or minus 22 over 6. No more square root. Based on the handout that we did either yesterday at the end of class or today at the beginning of class, when there's no radical or no I, you need to combine all these numbers together to get some exact solutions. So I'm going to split this up into 2 problems. I'm going to kind of scroll up here a little bit and work off to the side. So this will become -8 plus 22 over 6 and -8 minus 22 over 6. So with no radical or I separate the plus or minus sign to do out the math. In the top, when I have -8 plus 22, I'm going to get 14 over 6. I can divide those both by 2 to get 7/3. And the second one, I'm going to get -30 over 6, which is -5. So my 2 solutions are 7/3 and -5. This is 2 real solutions. No imaginaries, there's no i's anywhere in this example. I get 2 distinct x values. We're going to do one more today. So this is our last example. -8n squared plus 4n equals -18. With this problem, although it's a lot easier just to move the 18, that's going to leave me with a -a, which I said a lot of students in the past make mistakes. Although it's just one extra step, I want to move everything to the right side to turn my a positive. So I'm going to add over the n squared, the 8n squared, and subtract over the 4n to the right side of my equation, leaving me with 0 equals. Put them in order of standard form, so I'll have 8n squared minus 4n minus 18. There is a common factor of 2. You could divide all the terms by 2 before you do the quadratic formula, and you will get the same exact answer. But if you don't recognize that, you could just do the quadratic formula as is. I'm going to just do the quadratic formula as is, because I think the chances of you guys recognizing the GCF is probably not too high, although I would love it if you noticed it. It's a good SAT strategy too, so you don't have to work with large numbers, especially if a problem like this was on the no calculator portion. Go ahead and sub them in. Instead of x, I have n this time. So hit pause, try it on your own, and then check to see your answer was my answer, and we're trying to solve for n, which is like our x value. So go for it. N equals -b. I'm going to pause. This b is already negative. So -4 should turn into a +4. Plus or minus square root b squared minus 4ac all over 2a. So those two things I want to just mention again. The fact that the b was already negative and the formula was negative, change it to a positive. And it's also very important when you square the b that you keep that in parentheses because it was negative. You're also squaring the negative down. So when you square the negative 4 under the radical, it should become positive 16. That first term under the radical should never, ever, ever be negative. Always comes out positive when you square a number. If you don't put parentheses around it on your calculator, though, your calculator will tell you it's negative, and that's incorrect. The 4AC, I see two negatives again, a negative 4 and a negative 18. That'll turn positive. And then if I multiply those, 4 times 8 is 32. And then I'm going to multiply 32 times 18 to get a larger value of 576. And this is all over 16. Go ahead and add these together. 576 plus 16 is 592 over 16. All right, we got it down to the end. Now we got to look at the radical, see if that number comes out, breaks apart, or stays in. If I take the square root of 592, it's a decimal, not a perfect square. So we have to try to break that apart. And it's a large number. At least if you divide 592 in half, you're going to get 296. So you're only going to check perfect squares less than that, which does happen to be all the ones on our list. So you would do 592 divided by 256. So you should find those perfect squares in your notebook. That's a decimal. It doesn't work. 592 divided by, the next one would be 225. That one I'm not going to even bother to check. If it ends in a 5, it's not going to go into 592. The one before that would be 196. So 592 divided by 196, decimal. 592 divided by 169 would be next, decimal. 592 divided by 144, decimal. 592 divided by 121, decimal. 592 divided by 100, I'm not going to try that one. Obviously 100 doesn't go into that. So the next one out before that is 81, decimal. 592 divided by 64, decimal. 592 divided by 49, decimal. 592 divided by 36, decimal. We're going down to the tail end here. 592 divided by 25, I'm not even going to try. It's not going to work. So 16, and we got it. A lot of checking there, but 16 was the largest perfect square that went into 592. If you divided everything by 2 first and factored out that GCF, then you wouldn't have had to work with these large numbers. So I still have 4 plus or minus. Square root of 16 becomes 4 radical 37 over 16. I'm going to look at all my terms to see if there's something in common. I can't add or subtract them because of the radical, but I can look for common factors, and I can divide these all by 4. So my final answer is going to be n equals 1 plus or minus 1 radical 37. You don't have to write the coefficient of 1, divided by 4. Even though this looks crazy complicated, this is still 2 real solutions. There's no I anywhere. One of them would be 1 plus radical 37 over 4, and the other one would be 1 minus radical 37 over 4. If you wanted an answer that made sense, like if once we get to the real world problems, you would actually take the square root of 37, change it to its decimal equivalent, and then you could go ahead, add and subtract and divide to get 2 decimal numbers that would make a little more sense to you guys. Okay, and that's it for today. Tomorrow you guys are going to learn about something called the discriminant and work on a quadratic formula practice worksheet. Then the next day you guys will have a quadratic formula quiz and start real world. You'll work on real world for 2 days. And then we're going to do some review before a larger quiz. So the quiz will count double for this section because there's a lot of information about solving. We've then spent a lot of time on it. So this quiz will be a little longer and will count double. Talk to you guys later.